Science kids. Today we get to talk about something huge and spectacular, galaxies. But first, I have a question for you. How many of you have ever been 2 years old? Trick question. You've all been 2 years old. Do you remember what it was like to be 2? Where you are so small that everything seems huge, right? Hey kids, I'm glad to have you here for this week's science, week 28. And this week we are studying something gigantically, wonderfully enormous, galaxies. The world doesn't stop at galaxies though. There's so much to explore, you guys. But first I want to ask you something. Okay, have any of you guys ever been 2 years old? Trick question. Of course, you've all been 2 years old. Do you remember what it was like to be 2 years old? Where you're so small that everything is big to you, right? Climbing into the chair is a really big deal because you just can't get your leg up there on your own, right? As we study bigger and bigger things, we studied the earth, and we studied mountains, volcanoes, the depths of the sea. Then we study our atmosphere and how huge that is. And then we study our solar system, then the stars, the sun. We are small, right? But it's amazing when you think of it. I want you to remember that we worship this great big God who created all of this. I apologize, I got distracted for a moment. That is the hard thing about filming at home. But what I was saying is that we worship this great big God, and yet he cares for little us, right? So I want you to think about it. In Luke 12, it says, even the hairs of your head, like he worries about the birds and the flowers. He cares for all of them, and he cares for you, right? And yet he is so powerful that he stretches out the heavens, right? It's amazing. So today, for our memory work, I'm going to pull up my notes so that we can get the exact wording. What is a galaxy? A galaxy is a group of stars, solar systems, dust, and other objects held together by gravity. Our sun is on the edge of the Milky Way, a spiral galaxy. Whoa, solar systems. Wait a second, we just learned about our solar system. But remember, there are hundreds of billions of stars just in our galaxy. We've studied this already. And we found planets around at least 500 of them so far. Every star may have its own planets and moons and dust and gases surrounding it. And all of them together can spiral within a galaxy. That's what we're studying today. I put our memory work to Mickey Mouse. A galaxy is a group of stars, solar systems, dust, and other objects held together by gravity. Our sun is on the edge of the Milky Way, a spiral galaxy. Got it? So,
I don't get it.
Oh, Holly doesn't get it. Should we sing it again, you guys? No, you can replay it if you want. So I'm going to try to find a picture of my family with a picture of the Milky Way galaxy. Hold on, I'll be right back. So the word galaxy comes from the Greek word Galaxies, which means milky cloud. Because as we saw in the picture, it kind of is this band of cloudy looking stuff. So the term Milky Way galaxy is kind of redundant, don't you think? But that's our galaxy. The hard thing is, how do you study a galaxy when you're in it? It's kind of like trying to figure out the structure of a hurricane or a tornado while you're inside of it. That'd be hard, right? So when we look up pictures of the Milky Way galaxy, pretty cool, right? It's actually pictures taken from multiple observatories that we piece together like a puzzle. In the same way that, the model dinosaurs are made at museums. They take what we found over time and construct it and use research to get an idea of what we think it looks like. We've also have super high-powered telescopes or observatories that can see other galaxies, and based on what we see of our galaxy from inside, we can get a guess of how it looks if we were to look at it from the outside. Our galaxy, though, is 100,000 light years across. What is a light year? Do you guys know? It's the distance that light, one photon, can travel in a year. It's about 5.9 billion miles, I believe. So the speed of light in a given year, how far light can travel in a year, 100,000 times that distance is how wide our galaxy is. Our galaxy is several thousand light years thick, and it's the shape of a spiral. So it has kind of this cylindrical bar shape in the middle with two major arms coming out of it and two minor arms. Along those arms are lots and lots of stars. There are nebulae, right? Like the nebulae that we saw in Orion's belt when we were studying constellations. That's where stars are born, right? So there are not only stars with our galaxy, there are places where more and more stars are being made. So our solar system is about 25,000 light years from the center of our galaxy. Okay, so we're about halfway out. So here's the center, and we're about halfway out. And it takes, they estimate, 250 million years for our solar system to orbit the center of our galaxy. This is all spinning. And what they think happens is that every galaxy has a black hole where there's so much mass and so much gravity that it's pulling stuff. It's amazing when you study galaxies, how they work. Are you first graders feeling overwhelmed? Don't feel overwhelmed. This is meant to be amazing. Think of this. Your entire solar system is a little speck in here. And our Earth is a microscopic speck. And yet God provides for us, right? He gave us water. He gave us just the right atmosphere to breathe. He gave us just the right amount of sun to make plants grow, right? So our solar system orbits and takes about 250 million years. The arms, if there's a black hole sucking everything in and tons of gravity at the center of a galaxy, you older kids, why do you think we don't all just go and get sucked in? Scientists have come up with theories, and they think it's kind of like, have you ever seen a traffic jam? You guys, we live in Charlotte. Of course you've seen a traffic jam. You know, sometimes there's a car accident on the side of the road, and a car kind of slows down to see it, and then next thing you know, there's 2 miles worth of traffic, right? That first car that slowed down has already left, but meanwhile, the traffic jam behind it is kind of still stuck there, kind of slowly moving forward. That's what scientists think happens in these arms, that kind of at different speeds and various collisions and birth of stars and changes within this kind of slow everything down. And so they continue spiraling. And additionally, there are other galaxies around us, small galaxies and big galaxies. But our gravity actually can pull other galaxies in as well. It's amazing when you start to study this, guys. One thing, I want to take a quick break. Remember how I've told you about how sometimes we study areas of science not yet knowing why we care, right? I mentioned Isaac Newton didn't know all of the ramifications of studying the laws of motion, but now we have roller coasters and we can be very thankful that we understand the laws of motion. Albert Einstein studied quantum physics just because he was interested and wanted to figure it out. We have computers nowadays because of what he studied then. One of Einstein's theories can help us understand the distance of space. That light travels, we've been able to observe it at certain speeds here, but that it might, through portions of space, things may travel at different speeds. It's amazing. I hope some of you guys study this someday and can explain it to the world, and we'll all be better off for it. We have so much to learn. Today, I want to tell you, though, that there are lots of galaxies. Our galaxy seems gigantic, and yet we're one of hundreds of billions of galaxies. There are trillions and trillions of stars. When we study constellations, remember how I was telling you about constellations? Here's a hint. There are 88 constellations that we view from Earth. Kind of like there are 88 keys on a keyboard, right? So you'll always remember 88 constellations. The various constellations, like the W, that is super easy to find. Each of the stars appears like a flat line to us where it forms the shape W, but in fact, one star may be 200 million light years further than another one. Make sense? So, but they appear together from where we are. Some of the stars in our constellations are actually galaxies that appear as specks. Our naked eye can see about 6,000 stars on Earth, okay? But when Galileo first used the telescope in the 1600s, he was able to discover that a star to us might in fact be a galaxy with billions of stars. Isn't that amazing? So, let me see. Our galaxy has several smaller galaxies near it. If we could travel at the speed of light, the entire universe, so our galaxy has hundreds of billions of galaxies, or our universe has hundreds of billions of galaxies. What we've observed so far, if we could travel at the speed of light, would take 28 billion years to cross. Isn't that amazing? So I want to show you a picture. I'm going to look it up on my phone really quickly to show you guys a picture of all the galaxies that we've seen. Picture of multiple galaxies from NASA. Okay? I'm going to pull this up. And when the Hubble Space Telescope takes a picture, look at that. Each of those is a galaxy with its own stars and planets circling those stars. Every galaxy has its own shape. There are four main shapes. One is spiral. Ours is a barred spiral. We kind of have a bar in the center, and then everything spirals around it like a pinwheel. There's also elliptical, which are like round or kind of elongated. And then the last 20% or so of galaxies that we've discovered are called irregulars. Two of the coolest ones, I want to show you another picture of this, okay, are called the Magellanic Clouds. They're actually galaxies, but they look like clouds. And what's amazing with them, do you hear anything familiar? Magellanic. Magellan. Do you remember when Magellan's crew sailed around the globe? When Ferdinand Magellan was sailing in the 1500s, that's when these clouds, these galaxies, were discovered. This is around the same time that we started the School of Navigation, exploring around Africa. That whole era was shaped by the stuff we were discovering in the sky. I'm going to find for you guys a picture of the Magellan. I have a hard time pronouncing it. Look, isn't that kind of neat, you guys? Okay, so I want to show you some other pictures of galaxies because it really is quite spectacular. These are 23 of, let me see if I can find, yes, here we go. I'm going to just scroll through these because I think they are so worth seeing, you guys. I hope I can get a good enough picture. And I'll send this link to your parents as well. Isn't that amazing? That's a collection of galaxies. Look at that. Isn't that amazing? It's amazing to think how technology has changed over time and allowed us to get these pictures of things that are so tremendously far away, right? So how do we observe galaxies? There's gas and dust, and sometimes the dust actually obscures the light, so that we can't get as good of pictures of them. And so we use different types of technology. Look at that. We've also been able to observe galaxies that, because of their gravitational pull each other towards one another and can end up colliding. So some scientists actually believe that our galaxy is moving at about 100 kilometers per second towards the Andromeda galaxy. But don't worry, we're nowhere near each other. So it's still 6 billion years or more away from being near each other. So, but you guys, all of these galaxies, the way that scientists group them is by their mass, by their shape, by their behavior, their location within the universe. And the amazing thing is the amount of energy that, the energy from the sun, that's what heats the earth, allows our plants to grow, gives us food to eat so that we have energy to burn. Remember, we said energy cannot be created or destroyed. God spoke everything into existence and upholds it by his hand. Energy just changes form. And so you have these tremendous energy from the mass of things that can become heat and light and can create magnetic fields based on its motions. It's quite amazing. But we can use instruments here. We use radio observatories. We're going to use radio waves to essentially get pictures of stars and galaxies. We've also used gamma rays and X-rays. So things that aren't things that we can see with our eyes can still give us a picture of the stars. Isn't that amazing? When Galileo first used the telescope, it was pretty limited. But now we get such a big picture and we're discovering new stuff every day. So one last thing. So we can use radio waves, X-rays, gamma rays. Those are the highest energy type of light. Based on what we observe, scientists can make guesses about what happened in the past and what they think will happen in the future. In general, it's accepted that we think that the universe is expanding with its hundreds of billions of galaxies are spreading out. And from a biblical perspective, we know it says that God stretches out the heavens, right? But sometimes what's interesting is what scientists observe and make guesses about can come into conflict with what Scripture says. And so that's why it's so important for us to be grounded in what is truth and know that ultimately all these things glorify God, right? In Revelation, it says God will be glorified by the great and the small, right? And as we meditate more on the greatness of God and his power in creating such humongous things, I want you to remember to take wonder in him and in his creation, and in a sense feel really special that this great, powerful God delights in you. I don't know how many of you remember reading at the beginning of the year, but I thought it'd be worth sharing again. Pardon me. This story, Big and Small, Room for All. It's not a religious book, but I think it reminds us something very good. Big and small, big and small. And even you fifth graders, I know you can enjoy a good picture book sometimes. Room for all, big and small. Big sky, small sun. Big sun, small earth. Big earth, small mountain. Big mountain, small tree. Big tree, small man. Big man, small child. Big child, small kitten. Big kitten, small mouse. Uh-oh. Big mouse, small flea. Big flea. Big flea. What is smaller than a flea? What is smaller than a flea? A world of things too small to see. Big sky, big sky. What is bigger than the sky? So whether great or small, our God created all of them. And when we study them, I never want to hear any of you say that you're not a science person. Because anytime you study any science, it points to your Creator who loves you and delights in you. I'm going to send you guys some crafts that I think would be really fun while we're still stuck inside. If you like art, or go out still with the telescope while we have some beautiful evenings. I miss you guys, and I hope you have a great rest of the week. And Mrs. Cheney says hello as well. Bye, you guys.